I've said it hundreds of times. Terraform state files expose your secrets. Even if your plan output masks those secrets, your state file is still showing them in plain text, API keys, database credentials, passwords, everything. It's a silent security leak that's easy to overlook until it's too late. Anyone with access to your state file can grab your secrets. In this video, I'll show you exactly how to lock down your Terraform state using the new write-only attributes and ephemeral blocks in Terraform with 2 live demos. Let's first start with what not to do so you can see the danger for yourself, followed by the actual solution. All right, let's walk through a few scripts to get things started, and we're gonna get the Postgres database started with the scripts start Postgres dev shell. And this is just going to create a container for us, and you can see it's running port 5432. If you run docker ps, you see I have an Alpine container running here for us. So that is running our Postgres database. The next script is going to set up Vault in dev mode. So start Vault dev. This will get Vault running on port 8200, as you see here, and it's running in the background. And now we have a Vault server and Vault running version 1.18.4 working great. And we are actually running Terraform version 1.12.1. And for the purposes of this demo, we need at least 1.11 for Terraform. Excellent. Now let's go ahead and source our setup environment shell. Okay, so this will make sure that we have the proper environment variables to access the Vault cluster. So things like the Vault address, the Vault token is root for dev, and getting everything started so we can actually go ahead and run the demo. So the first demo I want to show you is showing you what it looks like to have an insecure Terraform state, basically showing all the secrets in the state file. So we're going to run scripts demo insecure, and we'll walk through this step by step. So we can see insecure Terraform secrets demonstration, and we've checked that the Vault server is running. This is for educational purposes, so don't run this in prod. We see Vault server is running, and here's our working directory. We're working on the examples insecure up here. So we're going to run this insecure demo.tf for Terraform. We're going to see some key differences where we're going to use something called data_JSON instead of data_JSON_WO for write only. And it uses regular data sources instead of ephemeral blocks. And all secrets are going to be exposed in the state file. So go ahead, press enter to run this demo. What it's going to do is going to initialize Terraform by running Terraform init. You can see it initializes successfully. The next step is to run Terraform plan, and we'll see that we have some sensitive value masking in the plan, but it does give a false sense of security. So the plan will look safe, but the state file is in fact not safe, and we'll see that. So the real problem is what gets stored after we apply. So go ahead, hit enter for Terraform plan. Terraform plan ran, and if we go up here, 6 to add, 0 to change, 0 to destroy. But what I want to point to is the masking that happens for our secret. So here's a secret, insecure database config, this KV version 2 secret. You can see data JSON. They're sensitive values, right? It shows sensitive values, which is great, but it gives you a false sense of security where these secrets will actually show up in the state file. So it doesn't show up in the plan output, which is good. It will show in the state file. So next is to go ahead and run Terraform apply to apply our changes. So this is going to do a bunch of things like push secrets into Vault, read secrets from Vault, and all that kind of stuff to show you that it's going to show up in the state file. So this has applied successfully. We have 6 resources that have been created, a bunch of mounts and KV version 2 secrets. We also have a database secret, dynamic secrets engine that gets initialized. So all that is good. Let's move on. So press enter to check the state file. Now we're going to go in and look at the state file itself and see what we find inside of that state file. Step 5, now let's examine the security nightmare in the state file. So checking what's in the state file. First off, let's run Terraform state list. This will give us all the resources in the state file. So we have a data resource, Vault KV secret, version 2, the database secret backend connection, secret backend role, 2 KV version secrets, the resources that were created, a vault mount for insecure database and insecure demo for the 2 KV version 2 secret and the dynamic database secret. So we can examine now the specific resources by running Terraform state show. And let's say we look at this KV version 2 secret. And if you look, you see that, oh, look, it's good. The data and data JSON, their sensitive values, exactly what we saw in the Terraform plan output, right? So if you run Terraform state show, this is masked, which again gives you a sense of false security. Also, if you run Terraform state show vault database secret backend connection for our dynamic database secret for Postgres, we see the connection URL here, and we don't see the username and root password going into Postgres, which is also good. But now let's see the real problem where the raw state file access reveals all our secrets. So if you run a bunch of grep commands to search for some secrets, so grep super secret database password 123, that's what we actually named the secret, and we're searching in terraform.tf state, you see that the secret password is in the state file. You can run another grep command, and here we go. We have a bunch of revealed secrets, database password, root DB password. All the secrets are right here in the state file, which is not good at all. You can also use JQ to extract the secrets. So using JQ with the command cat terraform.tf state with JQ, you can actually hone in and see exactly the database config with the database host, the password right there in plain text in the state file. You can also look for the database password, the root database password for the dynamic secret to connect Vault to Postgres. And if you run the cat terraform tf state, again, piping with JQ, you can see the secret here in plain text. If we run a quick ls command and look for different passwords in here with different counts, you can see that the number of password appears in state 24 times, secret appears 35 times, and for our specific password, the super secret DB password 123 appears 7 times. So that's it. There it is. The sensitive value masking is only for display, whereas if somebody has access to the state file, which by the way is up here, right? So if you click on Terraform TF state, we were just parsing it. But if you look here right away, you see the values are all in plain text. It's a big file. That's why we were just parsing it to speed up that process. The problem with this traditional approach, like we said, Terraform plan shows sensitive values. Masked Terraform state shows sensitive values also as masked. So these two can give you a false sense of security. But if somebody has access to the actual terraform.tf state file, then they will be able to see all those passwords in clear text. All right, so attack vectors, things like the state file stored in any Git control. So if you're storing that in your version control, your state files are exposed in CI/CD logs. It can be seen. Shared state backends, S3 or even Terraform Cloud, whoever has access to the state file will be able to view those passwords in clear text. Developer machines that are hosting state files, backup systems containing state files, all these can be exposed. So now what can we do? Can we do better than this? Yes, we can. And there is a new Terraform write-only feature with ephemeral blocks that can be used. So to do that, let's go ahead and shift gears and look at our second demo. And our second demo is run by running scripts and demo secure secrets.sh. So this demo will show the new secure way of handling secrets. You have to be running Terraform 1.11, so 1.11 plus. to be able to use write-only attributes and ephemeral resources, and zero secrets in state files. We will see that in action. Again, our Vault server is running, Postgres database is running. We are working in this directory now. Secure, we're inside of secure, so we're going to be running the complete demo.tf. The key security features is we're going to use now data JSON WO for write only instead of data underscore JSON. We're going to use the ephemeral blocks instead of regular data sources. And it includes real Postgres dynamic secrets that we'll see. All secrets are protected from state file exposure. So let's go ahead and click enter to get started. This will run Terraform init. And we see that this has successfully initialized our folder here. And now the next step, we're going to run Terraform plan. And we'll see that we're now going to use write-only attributes. That's going to show write-only attribute in the Terraform plan output. And ephemeral resources show us configuration unknown deferring. So hit enter. This is going to run Terraform plan. You can see again 6 resources to add, 0 to change, 0 to destroy. If we scroll up, we'll see that inside, let's say this Vault KV version 2 secret, we now have data JSON WO will show you write-only attribute. Okay, so nothing is exposed in the plan, similar to what we saw in the previous demo. The role here, you can see that nothing is exposed in the username and password for the Postgres connection from Vault. So that all looks great. So we can move on to the next step and hit enter for Terraform apply. Terraform applies successfully. Now let's examine the state file now that we are using the secure method. So running Terraform state list again, we see the same resources we saw before. If you run the command Terraform state show for a particular resource, you'll see that data is sensitive. The data JSON write-only attribute is shown here, mask. So nothing is shown, similar to what we saw previously. But here's the kicker. Now we're going to search the actual state file, and we're searching for that super secret DB password 123 that we found last time. And grepping that, nothing shows up, which is great. We can search for API keys like this one, grepping this one as well. Nothing shows up. Excellent. Extracting the write-only attribute values to confirm they're null. So we're going to use JQ again. So cat Terraform state and JQ and pipe that. You get null back. Same thing again. This time we are looking for anything data JSON WO once again. Instead of database config, we're looking in the complete app config, and also we get null. So that is also not there. So all write-only attributes show as null. Examining ephemeral resources, they shouldn't be in the state at all. So searching for ephemeral resources, Terraform state list, grep ephemeral gives you, of course, nothing. No ephemeral resources in the state file. And these ephemeral resources are used during configuration, but they're never persisted inside of the state file. If you want to examine the state file directly, you can, of course, go in here and start looking through the state file manually. If you want to go and quickly eyeball this, you'll see that there are no secrets stored in here, right? And we verified that with a bunch of grep commands and JQ commands. Now, let's quickly check secrets in Vault. If you click enter or type enter again, you'll see that right here, if we run the Vault KV get with the field password for this particular password, we see the password right here. So it is in Vault, but it doesn't show in the Terraform state file, exactly what we want. Same thing, we're going to check the demo secrets app complete secure config. You can see the entire data is right here, right? And none of that showed up in the state file, which is exactly what we want. Now, we can also show you that the dynamic database secrets work fine, and nothing, of course, shows up in the state file. The connection doesn't show in the state file. And by nature, dynamic database secrets, of course, have a time to live, so they will expire, and a new one will get created when you ask for it. So if you run the command vault read database, creds app role, that's the role we're working with, right away you get a password and a username. And it always gets a fresh set of credentials whenever you run the vault read command for that particular database secret. The key thing, of course, is to show you that none of this shows up in the state file. I just wanted to show you this in action, that it's actually working, and we do have a dynamic secret running. And we can use that dynamic secret that we just generated to test the database connection. So running docker exec into our Postgres SQL and providing the username and password with a command to select current user. And you can see right away the current user and the message that we saw here. So we are able to connect to the database with the dynamic secrets that Vault gave us. But the more important thing is that none of these secrets show up in the state file. Okay, let's examine the complete security model. Hit enter again. So looking at this command ls and looking through the Terraform state file, okay, no secrets are exposed. Again, running the command data JSON WO appears 6 times, but nothing is exposed, right? And the security analysis, what went right? So secrets show as write-only attributes in plan. Write-only attributes are null in the state file, which is what you want. Ephemeral resources don't appear at all in state. And secrets safely stored in Vault. Dynamic credentials work with real database. And of course, complete functionality with 0 state exposure. Right, so the attack surface eliminated, the same attack surface we were talking about before. All that is great. And of course, the before and after comparison is right in front of you here. And this all works great. Now, you can also run this command here. This will create a quick version update for us for our secrets. So if you want to make changes, you can see that, again, nothing gets changed, and again, nothing is exposed. So you can see here we are changing a password from version 1 to version 2, another change here, version 1 to version 2, right? So 3 changes, 0 added, 0 destroyed, but nothing gets shown in the state file, nothing is persisted in the state file, which is exactly what we want to see. All right, so that concludes our 2 demos. And very quickly, I would like to show you the Terraform configuration itself. We start off with the Terraform block, and when you're looking to use the newer features that we mentioned in this video, the Terraform write-only and also the ephemeral blocks, make sure that the provider you're using supports it, and make sure what version of that provider is supported for those new features. We have the provider vault block, as you see here, vault address, vault token, secret version, and so on. And we're mounting a KV version 2 secrets engine right here. And then we're creating a secret, a KV version 2 secret on this mount point and giving it a name, database Postgres. And here's where the magic happens, where we're feeding this through JSON. And we're using the data JSON write-only attribute. You definitely won't be doing this in real life. You'll be feeding this through environment variables. So something like var.password or something like that. And then feeding this variable through an environment variable into your Terraform configuration, because you don't want to persist this in your Git as you push this into Git, of course. The second piece here, we're adding a dynamic secrets mount point for our Postgres database. And then we're adding a connection. And the connection here, this is the connection URL. And once again, the username and password are in clear text. You shouldn't be doing this. Really, you should pass this as environment variables. But notice the password underscore right. And then we are going to create a database role with what the dynamic database secret is allowed to do inside of Postgres with the creation statement here. And then this is the ephemeral resources or ephemeral blocks piece that I wanted to show you for secure secret retrieval. And here we use the ephemeral keyword, and we're calling the Vault KV secret version 2 db config ephemeral resource. And from here, you can see that we're calling the mount point vault mount demo path, and the name is Vault KV secret v2 database config.name. And we're referencing the mount ID, as you see here, because we want to defer it until the mount is created. But this is really referencing that database underscore config secret right here, right? So we're basically creating this and then we're referencing it. You don't have to do it this way. You can definitely just use the ephemeral resource to reference an existing secret in Vault. But since we're creating everything from scratch, we're writing it to Vault and then we're reading it from Vault with ephemeral. We're also reading from Vault with ephemeral for dynamic secrets as well. So not just static secrets, also dynamic secrets. And part 4 is where everything comes together. And this is where we can create a new secret, call it the complete app config, complete secure config right here. And we're going to utilize the ephemeral resources that we just used to retrieve secrets from Vault. So here's a data JSON write only. Again, we saw this before. Application name, and here's the database URL. As you can see, format, and then we're feeding in a bunch of secrets from ephemeral, as you can see, and these are the ephemeral secrets that we retrieved from here, right? So we're feeding that in to generate a new secret. We also have the dynamic database username and password. And we're getting that from the dynamic database secret. And then we can feed other secrets as well if we want to, like API key, JOT secret, and a bunch of others. Again, this you won't leave in plain text like that. Feed it in through an environment variable. And then outputs, of course, you can have whatever outputs you like. But this is really what I wanted to show you of how you can use both ephemeral resources and also write-only attributes like this to make sure that nothing gets stored in the state file whatsoever. Ephemeral, again, it's ephemeral. It doesn't get persisted anywhere. And same thing with data JSON. Write-only, you don't see secrets in the state file. So that's it for this demo and video. I've had many people ask me about this particular concept, and I'm glad that finally HashiCorp has created something to help us. But again, this is dependent on the provider, so make sure your provider supports that. Thank you very much, and I'll see you in another video.